have to get off this planet. I'm not kidding. We have to get off this planet. Okay? I don't mean immediately. I don't mean necessarily all of us. And it's really just a question of timescale and motivation. Right? So we can think about this, for example, the way the astronomers think about it. Right? Earth orbits the sun, garden variety star, converts hydrogen into helium. It's been doing that for 4.5 billion years. The fuel tank is half empty. So the sun has got another 4 to 5 billion years to continue shining in our sky. And then at the end of that time, it's going to puff up into a red giant. And it's going to expand 1,000 times its diameter and completely engulf the radius of the Earth and destroy our planet. Probably on a Monday. Or we can think about it the way the Earth scientists think about it. Same kind of process and time scale. Tens of millions of years, over hundreds of millions of years, the sun is slowly getting brighter, and that's going to warm our planet. We've got global warming now. Wait, as the sun gets brighter, and some of my Earth science colleagues think that in 400 or 500 million years from now, the sun's going to get so bright, the temperature will be so high on our planet that all of the Earth's oceans and seas and lakes will be evaporated. We will live on a bone-dry desert world. So we have to get off our planet in 400 or 500 million years, right? We can think about it the way that my colleagues who think about asteroids and comets think about this kind of question, right? Asteroids and comets impact the Earth. If anybody's seen a shooting star, you've seen a small asteroid-comet impact. Sometimes bigger ones happen, like the fireball that exploded over Chelyabinsk, Russia, in February 2013, which was captured by like 500 dashboard cams. Why do the Russians have so many dashboard cams? You have no idea. They captured this. This was thought to be a 10 to 20 meter size small asteroid. Skims across the atmosphere, explodes in the upper atmosphere, shock wave, breaks windows, injures some people. Okay? But a relatively small event. Events like this happen every couple of times a decade. Bigger events like this, bigger ones, catastrophic ones, are more rare. And the last catastrophic one was the one that 65 million years ago, when a 10 kilometer size asteroid came screaming into the atmosphere, impacted the surface, created an enormous hole in the ground where the Yucatan Peninsula is today, lifted up enormous amounts of rock and dust, blocked off the sun, cut off the legs of the food chain, and killed the ancient dinosaurs. Probably on a Monday. Those are rare events. 10 kilometer sized bodies are objects that we can find. Astronomers do surveys. We know where all the 1 to 10, especially the 10 kilometer sized bodies are in the solar system, and none of them have Earth in their sights. That's great news, right? But the wild card is the comets. Comets are beautiful, right? They're spectacular. And people might remember the great comet of 1997, Hale-Bopp, right? Absolutely beautiful. They come from all over. They come from high in the sky, low in the sky. There's a huge spherical cloud of comets that circles the sun. And they're hard to predict. They come at us very quickly. They're traveling at super high velocity. Hale-Bopp is a 10 kilometer size chunk of ice and rock, traveling at a breakneck speed. And it missed the Earth. It didn't hit the Earth. It was absolutely beautiful. And they are beautiful things, but they're also sort of fiery death machines. Because if Hale-Bopp had been a little bit off, or any of the other dozens of comets like this seen in the past few centuries, just a little bit off, and they hit our planet, that would be another extinction level event. And those are rare. Last one happened 65 million years ago. Astronomers think that they happen every maybe few tens to hundreds of millions of years, so maybe we're overdue. Maybe we have to get off this planet in less than 10 million years, or a million years. But we have to get off this planet. Or we can think about it the way historians, cultural anthropologists think about it, right? Civilizations come, civilizations go. How long will our civilization last? Should we expect that it will last forever? Can we get along with each other? Can we find what Abraham Lincoln called the better angels of our nature, figure out how to live in peace sustainably on this world. Or not. Do we have 5,000 years to figure it out? 500? A couple of decades, maybe, given the nuclear brink we still find ourselves on. Making our species a multi-planet, multi-star system species is essentially a cosmic and biologic insurance policy against our extinction. But it's more than insurance, right? It's more than insurance. I believe that we are programmed at some genetic level, not just for survival and reproduction as individuals, but as a community to work to avoid our extinction at all costs. We've been able to learn how, with the help of science and technology, to learn how to predict the future and to understand, for the first time, the threats to our survival, not just as individuals or families or tribes or nations, but as a species. This is a relatively new thing. And I've been thinking a lot about this as a scientist, as an educator, as a parent. And I think that desire to explore, that desire to know, that desire to realize that future is part of what compels us to reach out, to explore, to climb the highest mountains, to dive to the depths of the deepest seas, to walk on the moon, or even just to try to crawl out of our crib at night. A combination of evolution and science and technology has instilled within us a desire to leave the nest. And that desire is just as strong whether you're trying to get to the next room, or the next planet, or the next star system. But will we do it? Will we do it? Carl Sagan reminded us that we've only just begun to wade out into the shallow depths of the cosmic ocean. Perhaps a little ways, perhaps ankle deep. Well, will we turn around and go back? Will most of us think that exploring space, learning how to leave this planet is a luxury that doesn't really affect our day-to-day lives? It certainly doesn't affect our distant future. Or, instead, will there be a global, species-wide consensus that emerges that says, yes, in fact, exploring space and learning how to leave our planet is absolutely relevant to our day-to-day lives and essential for our future survival as a species? If we can find that will, how will we do it? It's going to be hard, right? We don't live in the Star Trek universe. We don't have warp drive. We don't have transporters. We don't have Scottish engineers reminding us that we cannot change the laws of physics, Jim. Right? That's not the universe we live in. So we have to learn to crawl before we walk, and we have to learn to walk before we run. And there's enormous technical challenges. One of the biggest technical challenges is the distances and the times that it takes to travel in space. Space is big. Destinations are far. The Apollo astronauts took 3 days to get to the moon, right? The closest celestial object to us. A Mars rover takes 6 to 9 months to get to Mars, one of the closest planets to us. The New Horizons mission, which flew past Pluto last summer, spectacular pictures of the water ice mountains and dry nitrogen ice plains of the 9th planet, and it is a planet. That spacecraft took 9 years to get to Pluto. 9 years. So the distances are enormous, and the travel times are very large, and very frustrating to some people. Very frustrating to people like Stephen Hawking. I'll come back to that. I wanted to mention the Voyager probe first. Voyager These are two space probes that were launched in 1977. And they flew past Jupiter, Saturn, Uranus, and Neptune. They got sped up by the gravity of these worlds. And each of these spacecraft are now traveling at over 10 miles per second. Imagine something going through your neighborhood at 10 miles per second, right? These are the fastest things that humans have ever built and sent anywhere. And even at those speeds, 10 miles per second, it's still going to take them more than 40,000 years. 40,000 years to pass by the nearest stars. That's frustrating. That's a long time. We're still in contact with the Voyagers, nearly 40 years after they launched, still in contact with them. They've just passed out of the bubble of the magnetic field of the sun, popped out of it, so they're actually exploring interstellar space now, the space between the stars. We're getting direct measurements of what it's like there, and yes, they're robotic, but we're traveling with them. We've become interstellar travelers through them. Their nuclear power supplies are slowly dwindling. They'll stop communicating with us sometime in the 2020s or 2030s, but they will still be our messengers because of these beautiful golden records that they carry that you may have heard of, that have greetings and songs and pictures to be delivered to anyone who will listen from the pale blue dot from which they were launched. It's pretty spectacular, but frustrating, right? I mentioned Stephen Hawking before. Stephen Hawking and Russian billionaire Yuri Milner announced just a couple of weeks ago this new initiative to try to figure out how to accelerate small spacecraft to huge velocities using lasers, trying to get these little tiny spacecraft out to near the speed of light. So it might be possible to explore stars like Alpha Centauri, the closest star to our sun, not in tens of thousands of years, but in tens of years, in human lifetimes. Might it be possible to explore the stars around us and their solar systems in as much detail as we've been able to do in our own solar system in the past 50 years? Another big technical challenge is the cost. It's been estimated that traditional rockets cost something like $10,000 per pound to launch something just into low Earth orbit. And economists tell us that if we want to get that kind of enterprise into the economically sustainable realm of normal, routine civilization, like the airline industry, we've got to bring those costs down by like a factor of 1,000. Well, how do you bring the cost down by a factor of 1,000? You innovate. You do things like what Elon Musk and his colleagues do at SpaceX, right? You figure out how to reuse your rocket. You don't throw it all away. You try to land your first stage, and they and other companies are doing it spectacularly in recent weeks, right? Reusing those components, not having to rebuy very expensive parts, bringing the cost down into the realm of economic sustainability. And if that does happen, we can continue to bring the cost down. And Elon and others can realize their dreams getting people out to Mars. In fact, SpaceX took a big step this past week, announcing they're going to send robotic missions to Mars. This is a company, not a government. People forget what SpaceX's goal is. Elon Musk doesn't build rockets. He doesn't have that, get up and say, I'm going to build a Tesla or solar panels. The goal of SpaceX, the vision of that company, is to enable people to live on other planets. Everything that they're doing is towards that goal, including helping to bring the cost down of getting into space. This is also what motivates the asteroid miners, right? We need to live off the land. Can we find precious metals? Can we find water especially, right? The hydrogen for rocket fuel, the oxygen for rocket fuel, and to breathe, the liquid water to drink and to shield us from radiation. Can we find those natural resources out there and not have to launch them off the Earth? That's what's driving an entire industry that's being born to prospect and mine asteroids and other planets. And one of the other big challenges is just the environment that's out there. It's harsh, right? We've discovered that life on our planet, simple life forms on our planet, are incredibly robust. They can live in the deepest ocean, in the hottest near boiling water, in acid lakes, in frozen, salty tundra. Life on Earth is incredibly robust. Simple life forms occupy almost every niche that they can. More complex life forms, like us, or at least most of us. We require a limited range of conditions, and what's really, really challenging especially is radiation. So we have to wonder if, in fact, we have things we can learn from these simple organisms on our planet, like this organism called radiodurans. Simple bacterial-like life form can withstand 1,000 times the radiation of any other form of life on Earth. You know, we talk about CRISPR and gene editing, and these things are in the news right now. Might it be possible, using the examples from life on our own planet, to modify ourselves to better withstand these harsh environments that we'll encounter in the future? The urge to explore deeper into the cosmic ocean is what drives NASA, other space agencies, and SpaceX and other companies to try to get to Mars. The robots that my colleagues and I work with, the orbiters, the landers, the rovers, they're doing the reconnaissance. They're finding the landing sites, characterizing the nature of the terrain, finding the places that people can go to live and work and explore there. And I'm very confident it's going to happen. It could be NASA, it could be SpaceX, it could be the Chinese. My hope is it's everybody, but it could be as soon as the 2030s. It's really within our grasp to make that happen. And the desire to go even further, to really sail across the cosmic sea, is partly what drives astronomers to search for exoplanets, extrasolar planets, planets around other stars. A couple of thousand have been found now around nearby stars in the last few decades. And a small number of them have been found, a handful have been found to be Earth-sized. The Kepler Space Telescope looked at a tiny, tiny piece of the sky and found a handful of Earth-sized planets. If you extrapolate that across the entire sky, you end up with a number of 10 billion Earth-sized planets in our galaxy. How many of them are Earth-like? If it's 1 in 1,000, if it's 1 in 10,000, if it's 1 in a million, it's still thousands, tens of thousands, millions of Earth-like planets for us to explore. The urge to explore, the desire to leave our nest, to survive, to avoid extinction at all costs, these can all be satisfied through space exploration. They are being addressed through space exploration. I keep saying we have to leave this planet. We have to get off this planet. You're probably sick and tired of hearing it. And don't get me wrong, I love the Earth. Okay? Earth is my favorite planet. I love Mars. I love the Moon. Earth's my favorite. I have lived here most of my life. Most of my friends and family are from here. We have to get off this planet. Abraham Lincoln also said that the best way to predict the future is to create the future. We have to make sure that our art, our music, our science, our concepts of love and empathy, wonder, curiosity, the things that make us human, the things that for all we know are completely unique in the history of life in the universe, that these things thrive and survive. That is the future we have to work towards making, starting today, so that we're ready for whatever comes tomorrow. We have to get off this planet. We have to get off this planet. Won't you come along for the ride? Thank you.